Hey y'all! So in today's video, we will continue our Python for Data Science series and discuss data analysis with Python using Pandas. More specifically, I will discuss what Pandas is, how to get started with Pandas, DataFrame Basics, data cleaning, data transformation, data aggregation, merging and joining data frames, working with dates and times, data visualization using Pandas, advanced data analysis techniques, a case study involving real-world data analysis, and some practical examples. As always, this video is timestamped. So if you'd like to skip to a specific topic, feel free to do so by clicking in the timestamp down in the description. So let's get into it and let's tech talk with Tyler. So Pandas is a powerful open source library for data manipulation and analysis in Python. It provides data structures like DataFrame and series, which are essential for handling structured data. With Pandas, you can perform data cleaning, transformation, and visualization efficiently. Pandas was developed by a guy named Wes McKinney in 2008. The library was created to provide a more flexible and efficient tool for data analysis in Python. Fun fact, the name Pandas is derived from panel data, which refers to multi-dimensional data. Pandas offers several key features and benefits. Let's go over them. So regarding data structures, we have a data frame, which is a two-dimensional, size mutable, and potentially heterogeneous tabular data structure with labeled axes, which are rows and columns, and also a series, which is just a one-dimensional array-like structure with labeled data. Data cleaning and preparation, including handling missing data, removing duplicate, and data type conversion. Also, data aggregation and transformation, including grouping data, applying functions to data, and pivot tables. Pandas also integrates with other libraries seamlessly, such as NumPy, Matplotlib, and Seaborn for advanced data analysis and visualization. So to start using Pandas, you need to install it. The easiest way to install Pandas is by using PIP, the Python package installer. Open your command prompt or terminal and run the following command shown on the screen. After installing Pandas, you can import it into your Python script or Jupyter Notebook using the following code. Import Pandas as PD. This import statement allows you to use Pandas with the alias PD, which is just common convention among many Python developers. With Pandas installed and imported, you're ready to start manipulating and analyzing data efficiently. What comes after importing the Pandas library? Creating a data frame. Data frames are primary data structures in Pandas and are used to store and manipulate tabular data. You can create a data frame from various data sources. Let's look at two common ways, from a dictionary and from a CSV file. So you can create a data frame from a dictionary where the keys are column names and the values are lists of column data. An example is displayed on the screen. And in this example, we create a dictionary with two keys, name and age, and their corresponding values. Then we convert this dictionary into a data frame. Another common method to create a data frame is by loading data from a CSV file. This is done using the read_CSV function. The code snippet is displayed on the screen. This command reads the contents of data.csv into a data frame named df. And once you have created a data frame, it's essential to view and understand its contents. Pandas provides several methods to do this. So to view the first few rows of the data frame, use the head method. By default, head shows the first 5 rows, but you can specify the number of rows to display by passing an argument to the method, like df.head 10. To view the last few rows of the data frame, use the tail method. Similar to head, you can specify the number of rows to display by passing an argument. The info method provides a concise summary of the data frame, including the number of non-null entries and data types for each column. The describe method generates descriptive statistics of the data frame, such as the mean, median, standard deviation, and more for numerical columns within the data frame. These methods help you quickly get an overview of your data, understanding its structure, and identify any potential issues that need to be addressed. By following these steps, you'll be well equipped to start working with Pandas and perform basic data manipulation and analysis tasks. Let's go over some DataFrame basics. In Pandas, you can easily select columns from a data frame using the column names. There are two common ways to do this, and both are displayed on the screen. The main difference is the column names and amount of open and closing brackets. You can also select specific rows from a data frame. While there are multiple ways to do this, two of the most common methods are using LOC and ILOC, loc and iloc. The loc method is used to select rows and columns by labels or a Boolean array. The iloc method is used for integer location-based indexing to select rows and columns based on their index position. Slicing is also another technique used to extract a subset of the data frame by specifying ranges of rows and columns. So on the screen is an example of slicing rows and then slicing both rows and columns using iloc. These methods allow you to effectively navigate and manipulate your data frame, making it easier to perform data analysis tasks. So let's discuss data cleaning. Missing values can be a common issue when working with data sets. Pandas provides several methods to handle missing values effectively. These methods allow you to detect, remove, or fill the missing values, ensuring your data is clean and ready for analysis. To detect missing values in your data frame, you can use the isNull method. This method returns a data frame of the same shape as the original, with Boolean values indicating whether each element is missing, displayed as true, or not, displayed as false. To remove rows or columns with missing values, use the DropNA method. By default, DropNA removes any row that contains at least one missing value. You can customize this behavior with various parameters, as shown in the code snippet on the screen. To fill missing values with a specified value, use the fillNA method. This is useful when you want to replace missing values with a specific value, such as the mean or median of a column. You can also fill missing values with the mean of a column, as shown on the screen. Duplicate rows can cause issues in data analysis. To identify and remove duplicate rows from your data frame, use the drop_duplicates method. This method returns a data frame with duplicate rows removed. By default, it considers all columns to identify duplicates, but you can specify a subset of columns if needed. If you, for example, don't want to delete a column that you know has duplicates. Sometimes you need to convert data in your data frame to specify data types. This can be done using the asType method, which allows you to change the data type of a column. So overall, these data cleaning techniques help ensure that your data is 1, accurate, and 2, ready for analysis. By handling missing values, removing duplicates, and converting data types appropriately, you can significantly improve the quality of your data set and the reliability of your analysis results. Let's review some data transformation topics. Renaming columns is a common task when working with data to make the column names more meaningful and consistent. You can use the rename method to change the names of columns in your data frame. To rename multiple columns, provide a dictionary with old column names as the keys and new column names as values. The inPlace=true parameter modifies the data frame directly without creating a copy. You can transform the data in a data frame column by applying custom or predefined functions. This is done using the apply method. Mapping and replacing values are useful when you need to change specific values in a data frame column. You can use the map method with a dictionary to replace values based on a mapping, or the replace method to directly replace specific values. These methods allow you to efficiently transform your data, making it more suitable for analysis and visualization. So by renaming columns, applying functions and mappings, or replacing values, you can customize your data frame to meet the specific needs of your data analysis tasks. Next topic, data aggregation. Data aggregation involves grouping data by one or more columns to perform aggregate functions on the grouped data. This allows you to summarize and analyze your data efficiently. The group by method in Pandas is used for this purpose. So what is it? It's used to group a data frame using a mapper or by a series of columns. It returns a group by object that can be used to apply various aggregation functions. Aggregation functions allow you to perform operations like sum, mean, count, etc. on the group data. These functions provide a way to summarize the data in meaningful ways. To calculate the sum of each group, you will use the sum method on the grouped function. To calculate the mean of each group, you'll utilize the mean function. To count the number of occurrences in each group, utilize the count method. And other common aggregation functions include min, max, median, and standard deviation. Pivot tables are a powerful tool to summarize data by multiple dimensions. They allow you to reshape and aggregate data in a way that's easy to understand and analyze. The pivot_table method in Pandas is used to create pivot tables. Let's take a look at the code snippet on how to create a pivot table. So in this example, values is the column to aggregate. Index is the column to group by. Columns is the column to pivot, and aggfunc is the aggregation function to apply, such as mean. These data aggregation techniques allow you to summarize and analyze large data sets effectively. So by grouping data, applying aggregation functions, and creating pivot tables, you can extract valuable insights from your data and present it in a meaningful way. So what are some methods to merge and join data frames? Is that possible? Concatenation is a method to combine two or more data frames on a particular axis, either rows or columns. This is useful when you need to append data from one data frame to another or combine multiple data frames into a single one. Merging is a powerful method to combine two data frames based on a common column or index. This is similar to SQL joins and is used to combine data frames in various ways, such as inner join, outer join, left join, and right join. So a little refresher, an inner join only returns the rows with matching values in both data frames. If there are no matches, the rows are excluded from the result. To perform an inner join, you will use the merge function and indicate inner, as shown in the code snippet. An outer join returns all rows from both data frames with nulls where there are no matches, and the null is indicated with NaN. This means that all data from both data frames will be included, even if there are no matching values. To perform an outer join, you will use the merge function and indicate outer, as shown in the code snippet. And a left join returns all rows from the left data frame along with matching rows from the right data frame. If there are no matches, nulls are returned for columns from the right data frame, and they're indicated as NaN. To perform a left join, you'll use the merge function and indicate left, as shown in the code snippet. And a right join does the opposite. It returns the rows from the right data frame along with matching rows from the left data frame. Similarly, if there are no matches, nulls are returned for the columns from the left data frame. To perform a right join, you'll use the merge function and indicate right, as shown in the code snippet, making sure you guys are following along. These merges and joining techniques allow you to combine data from multiple data frames in various ways, making it easier to perform complex data analysis tasks. By understanding how to concatenate, merge, and join data frames, you can efficiently manipulate and integrate data from different sources. It's so powerful. Do you guys see the power in Pandas? To work effectively with dates and times in your data, it's essential to convert your date columns to date-time objects. This conversion allows you to perform various date-time specific operations and analysis. Use the to_datetime method to convert strings or other formats to datetime objects. So in this example, the date underscore column in the DataFrame df is converted to datetime format. Once you have datetime objects, you can extract specific date components such as year, month, and day. This is useful for creating new columns that represent these components. Similarly, you can extract time components such as hour, minute, and second from the datetime objects. Time series data is a sequence of data points recorded at specific time intervals, time series. Pandas provides several methods to handle and analyze time series data, such as resampling and rolling windows. What are these, you may be asking? I got you. These methods shown in the code snippets allow you to manipulate and analyze time series data efficiently. So by converting to date time, extracting dates and time components, and handling time series data, you can perform detailed temporal analysis and gain valuable insights from your data. Pandas provides built-in plotting capabilities to create various types of visualization. These plots help you understand the data better and convey insights effectively. So the plot method, that's used to create different types of plots, such as line, bar, histogram, and scatter plots. The code snippet provides context on how to create a line plot, a bar plot, a histogram, and the scatter plot that I just mentioned. So let's go into each of them. A line plot is useful for visualizing data trends over time. It connects data points with a straight line, making it easy to see the progression of data values. A bar plot is used to compare categorical data. Each category is represented by a bar, with the height of the bar indicating the value. A histogram is used to visualize the distribution of a data set. It divides the data into bins and shows the frequency of data points within each bin. A scatter plot is used to visualize the relationship between two variables. Each point on the plot represents an observation, with the X and Y coordinates indicating the values of the two variables. So you can customize your plots to enhance their readability and presentation. This includes adding titles, labels, and legends. You can also customize the style and appearance of your plots using matplotlib functions. Matplotlib is a comprehensive library for creating static, animated, and interactive visualizations in Python. You can use matplotlib to further customize the Pandas plots. Another cool library is Seaborn. Seaborn is a statistical data visualization library based on matplotlib, so it provides advanced statistical plots and better aesthetics. These data visualization techniques allow you to create informative and visually appealing plots. So we have Pandas, Matplotlib, and Seaborn. By understanding plotting basics, customizing plots, and integrating with other libraries, you can effectively communicate your data insights all within Python. You don't have to go outside to Tableau or Power BI. Let's discuss advanced data analysis techniques. Resampling is the process of changing the frequency of your time series data. This is useful when you want to aggregate data into different time periods, such as converting daily data to monthly data. The resample method in Pandas allows you to perform this operation easily. So in the resampling example, the data is resampled to a monthly frequency, and the mean value for each month is calculated. Rolling operations are used to apply calculations over a sliding window of data. This is useful for smoothing time series data or calculating rolling statistics, such as a rolling mean. So in this example, a 7-day rolling mean is calculated for the specified column, and the result is stored in a new column called rolling_mean. Expanding operations are similar to rolling operations, but they apply calculations over an expanding window, which starts from the beginning of the data and expands to include each new data point. So this is useful for calculating cumulative statistics. So in this example, a cumulative sum is calculated for the specified column, and the result is stored in a new column called cumulative_sum. The apply method, that allows you to apply custom functions to DataFrame columns or rows for more complex transformations. This is useful when you need to perform operations that are not covered by built-in Pandas functions. So in this example, a lambda function is used to square the values in the specified column, and the result is stored in a new column called new_column. So by mastering resampling and frequency conversion, rolling and expanding operations, and applying custom functions with apply, you can gain deeper insights and perform more sophisticated analysis on your data sets. Remember, this is optional. So the first step in any data analysis project is to import the dataset into a Pandas data frame and perform your initial exploration to understand its structure and contents. So this involves loading the data and using various methods to get a quick overview. These steps of viewing the first rows, getting a concise summary, and generating descriptive statistics help you understand the data structures, the type of values it contains, and any immediate issues that you may think need to be addressed. Before you can analyze the data, you need to clean and pre-process it to ensure it's ready for analysis. This includes handling missing values, removing duplicates, and converting data types, similar to what we went over in the beginning of this video. So these cleaning steps ensure that your data is accurate and consistent, which is essential for reliable analysis. So once the data is clean and ready, which could take a while, you can start performing analysis and creating visualizations to identify patterns and trends, such as applying custom functions to transform data and creating a line plot to visualize trends. You can also create other types of visualizations, such as bar plots, histograms, and scatter plots, to gain different perspectives on the data. Sometimes I like to do a lot of them just to see what visually speaks to me and tells a story. The final step is to interpret the analysis results and visualizations to draw meaningful insights and conclusions from the data. This involves looking at the patterns and trends identified during the analysis and determining what they indicate about the data. So for example, if you notice a trend in a time series plot, you can conclude that there is a consistent pattern over time. If you see clusters in a scatter plot, you can infer relationships between the variables. By following these steps, you can conduct a comprehensive data analysis project that starts with importing and exploring the data set, proceeds through cleaning and preparing the data, includes performing analysis and visualization, and concludes with drawing meaningful insights and conclusions that you could then bring to your stakeholders. So let me share some best practices and tips with you. Number one is writing clean and efficient code. It's essential for maintainability and performance. So here are some tips to help you achieve this. Use meaningful variable names by choosing clear and descriptive variable names, and thus will make your code more readable. Avoid chaining too many methods, as this can make code hard to read and debug. Instead, break them into smaller steps. Use vectorized operations because Pandas is optimized for vectorized operations, which are faster than applying functions row by row. There are several common pitfalls in data analysis with Pandas that you should be aware of to avoid issues. Be cautious with in-place operations. These can modify the data frame directly, which can lead to unintended consequences. So if you're unsure, avoid using the in-place equals true. Change it to false. Avoid modifying data frames in loops, as modifying these data frames inside a loop, as this can be inefficient and lead to unexpected results. Use vectorized operations instead. Check for and be mindful of common data issues like missing values, duplicates, and incorrect data types. This should be done at the beginning. When you encounter errors or issues in your code, use debugging and troubleshooting techniques to identify and resolve them. One of them is the try except block, and this handles exceptions gracefully by preventing your code from crashing and to provide useful error message. Also, utilize Python's built-in debugging tool like PDB to step through your code and inspect variables. Print out intermediate results to check if your code is producing the expected outputs at each step. And also check the documentation. Pandas has comprehensive documentation online that can help you understand functions and troubleshoot issues effectively. So by following these best practices and tips, you can write clean and efficient code, avoid common pitfalls, and effectively debug and troubleshoot your data analysis projects. Also use ChatGPT if you have any questions. That's what I do sometimes. So that's all I have. I hope that by now you have a better understanding of data analysis in Python using Pandas than you did a couple of minutes ago. If you have any questions, comments, or other Python topic suggestions, please leave a comment down below. Also, if you aren't already, subscribe to my channel. It's free. And click the bell icon to be notified when I post another Python series video. Thanks for interacting with Tech Talk with Tyler. I'll see you later.